Planning construction projects and tracking the vital status of resources are becoming increasingly important. We are therefore looking forward to our next speaker explaining how we go from the vision for future work and transfer to practice. Please welcome from the Technical University of Denmark, Professor Jochen Theise.
Good afternoon. I'm very happy to be here and presenting on this topic about how we can make a digital workforce even smarter. I'm from the Technical University of Denmark, and actually everything I showed today comes from students, PhD students mostly, and they deserve most of the credit. As a professor, you know, you can talk a lot, but in the end, there's workforce staff that actually helps you do it, and these are my students. A little bit background on AI or the transformation of the construction industry. I don't have to talk about anything of these topics, but things happen quickly right now. We are moving towards robotics and automation, mostly in research, but even in implementation. We work a lot for many years, if not a decade at least, on conversion of point clouds to 3D as-built models, and still not solved, a big problem to enable a lot of future solutions, even prefabrication modularization, so we know where the trends are. Question is, how does AI help us? And actually AI, not going to give you a lesson on AI, there's a lot out there that can be used. These are just a few of these topics. Natural language processing, we heard it earlier today, neural networks, deep learning, machine learning, computer vision, and so on and so on. And each one of those has probably overlap to each other, and yet you can help try to solve real-world problems with them. Here's a job site in Aarhus in Denmark. Actually, we're involved in this project that's currently under construction. I think that stayed here is about 6 months ago. And I want to give you an example about deep learning. Deep learning basically allows us to train models to yield some information, create some information we have not known before, or actually didn't know as easily, or couldn't get as easily. In this case, this job site is actually called the green construction site because we would like to avoid emissions. In particular, in my work package, it's emissions from construction equipment, greenhouse gas emissions, but even noise. And we have collected with a time-lapse camera thousands of images, and we are doing training to actually create information about what is our performance. And as you can see, these are just six images. It's rather hard for our brain to actually see what has changed from one image to the next. And here we can take computers that help us to automate this process. And that's one part of AI. It's actually to automate, to make things simpler and have us spend time on things that we actually should do as humans. And yet there's challenges with AI, or in this case, deep learning, because some images are not useful. For example, images that are completely black because they were taken at night, or there is fog, or there is rain, and so on. So these are challenges that we have to overcome, and as researchers, we design algorithms that actually can cope with that, that can fix it. How does it typically work? Some of you know already, but for those who don't, you actually have to train it. You have to actually go in manually and label every image for the information that you seek. In this case, we have 15 or 16 different machines, 15 machines that we want to know where they are. Are they rotating? Are they not rotating? And then we actually figure out what are they doing? Are they operating? Are they not operating? And actually, we also use portable emission measurement systems that tell us what is the state of the engine. Do they work? Do they not work? How much emissions do they emit? And so on. I go to that a bit later in my presentation. What I want to show you is a result from about more than 10 years ago, where we have done computer vision-based detection and tracking of construction equipment. And yet ask yourself, is any of these solutions ready and being applied in the market? Is anyone of you using this on a construction site if you work in the construction industry? Probably not, right? And yet we can detect when trucks arrive, how much time it takes to load. Typically 2 to 3 minutes is the productive state. Then they leave, go back in the traffic, come back, and we realize that around 5 o'clock in the afternoon, rush hour kicks in, and actually we shouldn't work anymore. Actually, we should stop because traffic jams occur, right? This is kind of what we have been doing, 12 years ago. And yet we still look out for solutions that we can simply buy. Digital twins, very quickly, we have a construction site, like we heard it, we have humans, project managers, construction workers, often forgotten. It's cheap labor, we often say, and yet we treat them like that. They don't reach retirement age, many of them. They wear out, their body literally wears out. We don't take good care of them, and yet they are a vital resource for every of our projects. We know that if we have to do some maintenance at our home and can't get people signed up to do the job. And yet we have building information modeling, a method has been introduced for a couple of decades, has become really popular about 15 years ago. And yet where are we with BIM? We create static models, and yet maybe they are not suitable for the construction phase. And here comes data. We talked about data a lot. I think data is one ingredient, but actually I'm not interested in data. I'm interested in information, and even more, I'm interested in the next level, knowledge. And yet a digital twin can enable us connecting these dots, and AI is a component of generating information that is then eventually visualized or available for decision making during the construction phase. And of course, we know that we have services that we can relate back to the users, to the managers, and these are tools, dashboards that present them the information in an easy, accessible way. That's good. I would call this human-assisted artificial intelligence, where we actually try to give us hints of what we should do better and learn. I want to give you a motivating use case, and I've been in this for about 20 years, and it's construction safety. Just 2 examples from Hamburg. This was in November, and then one from Stockholm. Many of you in Sweden know about that. 5 people got killed on each side. Yeah, shouldn't have happened, but for our records in Sweden or even in Denmark, 5 deaths is a lot. And in Denmark, we have, I think, 4 last year in total. Yeah, that's a lot. It's a shocker. It's a really shocker. For a long time, we have focused on the safety pyramid, where we focus on eliminating fatalities. Actually, research has told us we can't eliminate fatalities. They're so unpredictable. You can't design them out. And yet then we thought, okay, let's design out injuries. And then later on, we focus on close calls, events that almost kill someone or injure someone. And yet we figure out that doesn't lead to the goal, because the accident statistics tell us we are leveling out. We don't achieve the goal of 0 accidents. And that's where we focus currently on HECA, high energy control assessment, where we actually take the energy level of the root cause into account and the impact on the human body, because the activities you perform can be quite different or can have a quite different outcome, depending on the energy that is involved in the task. And then we focus on prediction for proactive control. I've come up with that term also 15 years ago, where I said, really, we have to change this way the industry works. Yeah, and digitalization should be seen as an enabler, not as a replacement of human beings, but trust me, yes, jobs will have to change, whether people like it or not. A Swiss cheese model, when I talk to safety engineers, they always tell me, it's an old hat, and yet I would still challenge them in saying each one of those layers that you could think of a cheese, like a Swiss cheese, which has a hole, which basically, if you run through all the holes, you actually hurt someone or damage equipment. It should have actually a layer, an additional layer. And this model was invented 30 years ago. And I believe there must be an additional layer called digitalization. And that's one way to move forward. A lot of the industry is resistant on that, because they think they can solve the safety problem through management. And I agree with them, it's a good way, but it's not the ultimate answer. So what is a digital twin? Think about a construction project that has stakeholders in place, and we have the knowledge domain that these people have, or actually rules and regulations from governments, and they can help us to create a digital representation of the object or the building or the infrastructure that we want to build. And yet, through the knowledge domain that we have, we can actually analyze what we want to build. And I call this prevention through design and planning, because we can do this ahead of our project start or before workers start working. I'll give you an example. This is how it has been done a long time ago. I must give credit here to Skanska Oy in Finland, which has actually helped us with a little seed grant a long time ago. And we analyzed with them, how do we actually bring BIM on board to solve this problem. Because people literally use CAD drawings, printed them, and draw on them to figure out where the hazards are. Balconies, etc. This knowledge sits all with this expert, a great guy, by the way. And yet, why don't we go to this level where we have a BIM model and actually can design these safety elements like guardrails, hole covers automatically? Ask for these tools. Do they really exist in the market right now? Maybe not. And yet, collaboration, a big word today, I know it. Teamwork, right? It brings everybody together that works in a team, from structural engineer to architectural engineer to safety engineers, and so on, project managers. I'll give you an example why this matters, because in every country, codes and regulations are different. You actually have here a benchmark model. Like in research, we always measure and we need to compare to say, does it work what we actually create? And here is our algorithm that applies to EU regulations and to the US regulation. And you can see, even though we have a tiny workspace, just less than half a meter or half a meter, it makes a difference in certain countries. Yeah. Look here, this is when our algorithm actually is being tested, and we can figure out that these spots are actually protected. These guardrails are automatically planned. No human interference. And now there's some people out there who design these guardrails manually. Great work, by the way, but we do it automatically. And I think we need to provide simple, easy-to-use tools that practitioners out there who have no experience with BIM, don't know how to use Revit or any other software, can apply. That's how it has to work. Here you see a difference between before and after, and you can clearly see the difference. And of course, actually, there is an object that had no guardrail. You probably have seen that. If not, you need to open up next time your eyes. You can see that these things are actually quite well executed. And yet we actually take the 4D schedule in place. Here you see a guardrail that is not in place because there's actually a lifting operation coming up on the next day. Like I talked about the construction schedule, actually the tool that we have developed allows you to simulate and predict where these falling hazards occur. Yeah, these are shown on the left. Top, you see this 7-story building. There's workspaces that actually as you move the building up, appear and then sometimes disappear because you have to install the facade element. Likewise, you can track the quantity. You can actually associate, I'm not talking about cost when I talk about safety, rather than the investment. You can talk about the investment in safety. You can quantify it, and actually you can create, according to a baseline plan, alternative plans, for example, not having just one crew, 2 crews, thinking what does the impact on the construction site look like if I use multiple crews instead of one, and also the impact of applying it to safety. Yeah, nobody will be left out on that point anymore. So I go in here a little bit into AI for prediction, for inspection and compliance checking. Now let's assume we have designed out these hazards, very important first step. We design our hazards before they go into the workplace. We actually want to go in and actually check. Here's augmented reality, an application we have developed 5 years ago, yet no tool available in the industry. Actually, it still includes the human here in terms of figuring out, is there an issue? We draw the information from the BIM model once, because we have georeferenced ourselves to the location, and here we can visualize that there should be a guardrail in place. Of course, this has been staged, but again, we have a prototype. Hey, industry, pick it up, no problem. We move forward. Of course, we envision that we can fly with drones. So unmanned aerial vehicles. We can create point clouds. We can analyze those point clouds. And there's a process we have developed. Of course, we write research articles, more than 60. But according to these combinations of hazards that could exist or hazardous conditions that could exist for guardrail, we can analyze it. This is a job site again from Finland. I must say the Nordic countries are really good, allowing us also to get access to job sites. Not always common, no. We challenge that industry for that. And we actually fly with drones to see, is a guardrail element missing? And our algorithm tells us, yes, the middle board is missing, or the toe board is missing, or the top board is missing, yeah? So actually autonomous flights with UAVs is not an issue. You can actually then have this communicated through a dashboard. Of course, we don't focus on the dashboard. That's an easy task. About computational processing time, it's, I think, very important for software companies to figure out, is it scalable? Can we do it on a real project with thousands of objects? Yes, it is. You can see it here. Internet of Things, it's all about knowledge graphs and queries. So we have to actually formalize the knowledge that is in our brain, actually bring it down, to a computer and tell them, do it this way. So here we have a knowledge graph, and then we can, here's a knowledge graph actually for struck by falling objects from above, assuming we have an operation with a crane lift and a load hanging on the crane hook. Here is a knowledge graph on that end, where we precisely define what situations can occur. And then we can actually do a query. Here I have illustrated in a cross-sectional view of an operation where a load could drop either, you see the red space here, which is a workspace that by itself is hazardous, but it could also drop on a worker at the bottom, which could be then likely deadly. Yeah, but this is again a paper we have written on this topic. Really nice work from my student, Carsten Johansen, excellent PhD student. And then we actually, once we know where these things should occur, we actually use again AI on computer vision, on a camera to detect workers, are they below the crane load or not? Again, here is some results that we have been doing. And again, the industry has been looking into that, of course, already. But here it would be nice to pinpoint and georeference where are these workers on that job site. And here we take this safe BIM we have created earlier. We take it for that stage of the construction schedule. You see it here on the bottom left. Red means fall hazard, and yellow could be a struck by zone hazards from equipment outside. But more or less, we also take an RTK GNSS tag on worker. On a worker, that's a GPS device that is really accurate, down to the centimeter level. Of course, only outdoors. And then we combine and fuse the data. Data fusion is a big thing too. And here you see a result about the trajectories from 5 workers throughout half a day. And you actually see the crane swings. And every time a load is above a worker or very close to a worker, actually creates one of these red circles. It's really interesting. Such information hasn't been created yet. And actually AI throughout this process has helped a little bit. Yeah. You actually can pinpoint and say at what time these situations occur. We suspect from other data from ground moving vehicles around lunchtime is a big issue, or break times, because the sugar level in the body actually decreases so much that people pay less attention. But you can figure out probably other things. That around 10 o'clock, trucks arrive on the job site. It suddenly gets very busy, a bit chaotic, and things happen, right? Of course, this subcontractor was very skilled in handling that. Here's a job site we had in Munich, actually doing similar experiments. Actually, we used the RTK GNSS work here as technology as well to track locations. Don't get confused. We scientists, we actually like busy diagrams. But you see here a lot of trajectories and actually the safety envelope around a machine where people really shouldn't enter because it gets really dangerous. And we can find those. We can find those interactions once we process the data and actually predict where future incidents are very likely to occur. And actually, in this case, we want to install concrete barricades, if they have not been already in place, to protect the workforce. Yeah? So there's a new dimension actually helping the safety manager or safety responsible person to actually put things in place they haven't thought about. Or actually measure what they have designed originally, has it been compliant? Has it actually been good? So giving them tools into hand, measuring that their work was actually good, and actually praising people. Active personalized learning, next level. So right now I presented already 3 stages. Safe BIM, designing out hazards in the first place so they don't appear in the work stage. Second is to track what's going on and actually take real-time control, like fixing it if needed. We have, by the way, also technology on that. I'm not showing it to warn workers in real time. That exists as well. I'm not showing it because it has nothing to do with AI. And last but not least, actually, we need to look into how do people learn? Yeah, workers. Yeah, of course, workers are also people, humans. Here is an AI training game. I know several companies do have virtual reality safety training games. nowadays, really good ones actually. Some of my students actually graduated, went to big engineering firms, at least in Denmark, and built one game. I'm very proud of that student because, hey, he made it happen, right? Designing a product that actually helps. That's not this game, that's our game. This is already 3 years old. We won a prize at a big safety conference. But here's one little thing of how we actually can help people, workers actually train, expose, help them understand what are these hazardous conditions. But more than just creating a visual interface, they actually collect data about the users. And that's very important. That's a big difference. We actually see where they walk inside, and you see here all these different trajectories with different colors or different players. And the bigger the circle is, the more dangerous the event was. It's a bit difficult to see, but there's an excavator being very close to one of the players. And we believe that this shouldn't have happened. So we actually have data available, objectively collected data that give a trainee their feedback that they need, the personalized feedback in terms of helping change their behavior before they go out on the construction site. Does that make sense? Of course, this is just one training scenario. We believe that this can be the steps can be safe BIM. We can take real data from a job site, but we also can train them. And I think there's a good lessons learned to do it. As a matter of fact, often people hammer down on workers, especially in companies which don't have a good safety culture. We believe that such games can also be used for praising the workers, to reinforcing what they have been doing well. I think there's also a mind shift that has to happen. Here is a tool, actually I've been using it, where we actually take augmented virtual reality. Many of you know augmented reality and virtual reality, but there's something in between called augmented virtual reality. Actually, I think we have been one of the first ones also gutting an angle grinder and actually taking that into a hazardous learning game where you're exposed to many different hazards. And what you see here, I think we need sound here if it's possible. And you can see my reaction, really shocking. As a matter of fact, you see that with participants. And this is a replication of a true incident in the real world where somebody cut in a pipe and killed 5 of his colleagues in Germany on a chemical plant because they didn't know that there was still liquid flying through one of the pipes. One of them was shut off, the other one not. And it led to the death of 5 people. You can imagine, right? I mean, augmented virtuality here in this case was used to enhance the haptic or the feeling, having a real machine in place and turning it on and actually ensuring that it feels like in reality is a real big game changer. By the way, sound as well. Sound in VR is very important. Maybe quickly AI for other purposes. I think I touch here a little bit on the other points people have made before. Actually, a Danish contractor, Arslev, has been working with us on actually tracking emissions. Here we use portal emission measurement systems as well as simplified emission measurement systems to ensure that we can track emissions. We can very clearly see when we exceed with the machine the emissions, when not. We actually did also noise simulations. It was mentioned just in the presentation before. Actually, there's a lot of stuff that hasn't been linked yet. Simulation tools and building information modeling. One of them is actually noise, or was noise. But here you can clearly see that keeping an old structure in place is actually a good thing, not tearing down everything and then building new, because the noise doesn't penetrate back into the city, actually towards the harbor front to the bottom right. I think you can see that here as well. Robotics, also a big playing field for AI. What I very much like is the circularity concept. We should reuse materials, especially prefabricated materials. Here we have actually come up with a 3-month project of 2 master level students who had no understanding of BIM at all, but yet a little bit experience of robotics. And they actually came up with design alternatives that a user can select in the middle of, let's say, a lifespan of a building. So first they choose a design, and after 40 years they say, okay, I want to restructure my building. Hey, let us build the new type of building, like version B. And what I'm showing you here is 20 times faster than in reality, But a robot very much applies actually AI and doing a lot of the tough load of figuring out where things are and what I need to take. So, of course, a human currently supplies the materials. Here we have a bathtub module that's being placed, but the robot otherwise can figure out where and how to place based on vision-based detection and tracking. Yeah, and of course we use QR codes just for control. But here the building is set apart. This was the scenario A, and actually now, let's say the owner says, I want to have model B, and the robot actually takes the existing pieces back into place, but builds actually version B. I think it's pretty cool what can be done in a lab environment like that, yet a robot arm like this you would never place in the real world. It's way too heavy. Conclusion path forward. I think we need at least a triple transformation in the AEC and operation phase. From linear to circular. And with that, I don't mean necessarily circularity, but I mean linear to the information, right? It's not top down, actually. We should recycle the information, actually bring it back to the people so they can use it on the next project. We have experience. We have a lot of trade workforce and engineers and managers out there that have a lot of experience. We need to gather it as quickly as possible and actually create evidence. Yeah? Data is there, but the data is raw and not meaningful. We need to use evidence so people trust it and apply it. And then reactive. Yeah? Many of the things we do nowadays, we'll do it on the next project. No, we need to be proactive, doing it right away. There is, the Bradley curve. If you're interested, search it at some point and try to figure it out. But as a matter of fact, there's industry standards, and yet many of the industry standards don't hit the people who make decisions. I think we need to work on both fronts. It requires behavioral change. Importantly is in the construction domain. Yeah? People are not convinced if you impose it just on them. You need to make them use it. Yeah, and then maybe Matrix and Minority Report, you know those movies eventually. And then there is even that one. Yeah, have you read this book? Of course we have to think about it, right? What will happen in the future? And it's scary, and I trust you, even in my university, many of the jobs will not exist in 10, 15 years from now. Be ready. You smile, but it's not even I think what's happening. And I close on this one here. Hey, ChatGPT, finish this building, right? This is actually sponsored by a company who does recruiting for tech in construction. I believe in this, right? It's not just tech, it's humans. Yeah. Economists, what do they think? We heard it at the very first keynote, right? But here it is, right? Thank you.
First you give us hope, and then you scare us. Good work. Come, Jochen, please join me here, because, you know, I would like to actually go back to the poll question. Don't show any results now, guys and girls, because I would like to ask you, Jochen, do you remember the question?
Yeah, I know.
Do you think the building industry have the right tools for building safety and collaboration today? What do you think people will respond? Percentage?
Knowledgeable people or tech-savvy people?
Well, I don't know, this bunch.
Yeah, I think it's a mixed answer that we will see. Many may say no because they don't know what. They may not know this area, and yet I think that's why the response will be rather on the lower end.
You're quite a pessimistic guy.
No, I'm actually very optimistic. I'm surprised that nobody is laughing more in this presentation.
No.
I gave.
Okay. Yes, please show us the result of the poll number 3 there. You see? Do you still think that's a bad figure or a good figure?
So 4 says high, right?
Yes.
High implementation. Oh my gosh.
Yeah, I told you were too pessimistic.
I have to work with all of you. Or you need to tell me what are you using. Because
we can get back to that. Jim, I would like to have my iPad on questions later on because I forgot that one. Meanwhile, I have to introduce, because we are going to be joined by a panel, of course. And here in Stockholm, we are joined by Timo Kangasmäki from YIT. Welcome. Give him a hand. Thank you. before I continue to our panel in Oslo, are you an architect or an engineer? What are you?
Architect.
Architect. And what is YIT for those who don't know what that is?
YIT is an acronym from Finnish, and it means like a general engineering company.
Perfect. You're very much welcome. And in Oslo, we are joined by Marius Alnes from Norconsult. Welcome.
Thank you.
Yes. And beside you, we have Knut Ramstad from Nordic Office of Architecture. Very much welcome, both of you.
Thank you.
I love the waving style over there, Knut. Very good. Actually, I would like to start with you, Knut. Were you surprised by the figure that we have in the poll? Jochen was a little bit pessimistic, and then he was optimistic, but then he asked a relevant question: who uses what? What is your reflection?
I think they're all lying.
What do you think the truth is?
What kind of tools are they using?
Sorry, pardon? Once again?
I'm a little bit curious about what kind of tools they're using.
True, true.
As well.
Marius?
Yeah, I think it was a result that was quite, I don't know, I was expecting a little bit lower in the scale there. So I was a bit surprised for that.
In a positive way. In a positive way.
Yeah.
I think we have an echo all the way to Oslo, so I hope I will try to talk a little bit slower. When you heard Jochen, do you have any other curious questions about how we can use AI in other aspects?
Sorry, the question was for me?
Yes.
Or okay, yeah. I'm curious if we could use. I think it was a really good presentation, and the safety aspect is really spot on. I think I was wondering if this Internet of Things and the AI, if you could use that, you were showing some guardian rails and etc. But I guess the same thing can happen with use of helmet and tracking of that kind of things as well.
Yes, Jochen.
Well, I think the industry is having very good best practices, and in my opinion, many of them already hit the target. And yet there's many things that digitalization can actually assist in solving. I'm not sure if I quite understood the question, but I think there's ways to improve. And I think digitalization can be an enabler and not, as I said earlier, a replacement of humans. And yet it's not just wearing the helmet or not. I think we have to go to the next level, take as much as we can right now. I don't know, at YIT in Finland, you guys have also very good approaches.
Yeah, I think that these safety guardrails and so on, it's been like the modeled mandate for like more than 10 years that all of the structural engineers have to do the guardrails and all of these coverings for the halls. So I at this point I don't see why of course they need automation, how they do it, but it's like mandated to have it.
Yes.
But then when it comes to like the question how else it could be used, I would say that this image recognition could be used more or less like when doing the delivery of different phases and actually helping us within the liability phase of our projects. So if we find out that there's like some kind of a fault in some kind of let's say equipments or products, then we can track on where these are installed and so on.
Yes. I mean, from my point of view, safety is one part. If you think about the return on investment, it's probably 3 to 1. Every euro or whatever currency you invest in safety actually yields a multifold in return. And yet, I think there is a lot of alternatives that you typically have. And construction sites change so dynamically, and the progress is so hard to track. I think we can use AI to actually generate alternative plans that actually are being used right away, right? That you adapt quickly to the change. And I think that's where we humans challenge, because we have so many things to put into place to make solid decisions. And I think AI is a good way to process all of that data, like you said, automatically, because we don't have the time, right? It's very challenging in the field out there. Yet you have companies, one standing next to me, who do a really good job, from what I've heard, to deliver projects as good as they can. But many others maybe don't belong to that pool. We need to help them as well.
Knut, Nordic Office of Architecture, is there a lack of something in your daily work that could improve this artificial intelligence that we can use more of?
Obviously, we are experimenting with AI all the time, and I'm going to give a presentation after work today with lots of examples of how we can really introduce AI into different work and different aspects of designing. And but what I really think is key here is to actually start with what are we to solve. And obviously, when you have these examples that were shown, these are very much based on rules and rule-based. And in design, it's not that simple, because we are generally a little bit more, we're trying to have a very free and very open mind when we start the design work. So there are absolutely challenges in introducing AI to design work.
Could you elaborate a little bit around how if there are any obstacles that you say this is not a way where we should work with it, and here is the way we should work with it?
We definitely see enormous development on AI tools. Personally, I believe in introducing and implementing AI tools in already established software, and assisting us to gather information, make use of the information we need, create a feedback loop, and play together with the AI to produce better architecture. So it's definitely happening a lot. So we see every 3 months there's a revolution, something new coming, and it's definitely exciting times. And personally, I believe that AI is going to be, like in some Adobe products, it's so well integrated, so you don't even think about it. It's just a way of fluently working.
Marius, can you predict a little bit the future, at least 1 year ahead? Do you think our figures will increase a lot when it comes to using artificial intelligence from 1 year from now? We saw in the poll that 1/3 work already with artificial intelligence in some way. How fast can this increase?
Well, as a structural engineer as well, from 1 year from now, we often get models and etc. from Knut and architects, which we want to optimize the structure of the building. So I have been looking for some software where this can be done, and with the help of AI and the right tools there, hopefully it will come to a time where the structural engineer can get a model from the architect, and it can optimize, because we get hundreds and hundreds, or it's many solutions for how the structure can be solved. But from 1 year now, I don't know, the evolution for AI is really high. But on the other hand, if you see some decades behind, they were also talking about AI. So I'm not sure if I can get a really good prediction for that.
Any comments from you, Timo?
I really hope that, I'm not sure if it's going to be within 1 year or so, but I really hope that the AI will solve the issues that we have currently within our design processes, that there is, it's lacking the mandated data, and it is always clashing with different disciplines. And I hope that AI will come and give us some quick solutions on that one.
I agree. I think one important part is standardization. That's one way to assume that everything works together. And I think there's a lot of issues with that currently, where a lot of companies use that and the others that, and it's hard to actually collaborate. It's difficult.
Yes, and we haven't talked a lot about that, but can you say something about the GDPR? Well, the GDP issue, because there is an issue.
Well, many believe there is an issue, but there is, of course, regulations that intend to protect the workers' rights, or whoever is in a picture of a camera, in an image, for example. But you can also ensure that data stays on the job site. I think many have that mandated. It doesn't leave the job site, so it gets processed, and the original data is being deleted, or images, if they're used for visualization purposes, are pixelated. That's one thing for computer vision-based approaches.
Finally, Oslo, active learning by using AI. What is the next step to increase that in your where you work? Let's start with Knut. Short answer, please.
You know, I think the combination of XR and AI is really interesting to really involve users, clients, architects, engineers, in building a collaborative platform that is accessible to all. That's key to produce better quality, to get the decision-making processes more accurate, more effective, and to ultimately get a higher quality on the building with all its aspects.
Thank you, and Marius.
Yeah, totally agree with Knut. To have a common platform for collaboration, because we are humans, we need to put our mindsets together, and with the help of technology and software, I think that's a good power to the future.
So we are back to the ends again. Collaboration in order to use the artificial intelligence even more, correct?
Yes.
Yes. Jochen, final words.
I think there's a lot of potential. We need to tap into it. And if you give a short answer on the active learning, the Femabel project in Denmark, between Denmark and Germany right now, there's 80% foreign workforce. And many of them are young, and actually I think you can engage them too by using other means of learning. And one of them is actually using virtual reality. So there's lots of potential, in my opinion.
Thank you very much. Jochen, Timo, Knut, and Marius in Oslo.